Did you give it 1020? Did you give it 1020? Yes.
Yes, actually. You don't have your own video, you have the big one.
Unmute me. Hello, can everybody hear me? People online? Can you hear us? Yes, somebody said yes. Perfect. Let me move a little bit. Yeah, here. Okay, so good afternoon. I'm Dr. Posani. I'm the Director for Engineering, and I'm here to welcome you to the Create at CQ-AState 2022. This is our second event. The first event happened 1 year ago. Let me also give you a little bit of an idea of why we have this event. This, in fact, this symposium was created in Jonesboro in our main campus 12 years ago. The objective of the symposium is that students from undergrad and from graduate studies can present their final projects, their custom projects, their research projects. And the idea is to have it all concentrated in a few days. In Jonesboro, from last Monday until today, they have their event, their symposium. Here in Mexico, we have it from today until Friday. So it's 3 amazing days that we're going to see a big variety of different types of projects where you're going to see what our students, what our community is creating, right? So for this event, today we have, well, it's separated in 3 days. Today we have 5 presentations from different teams from business and engineering. On Thursday and Friday, we continue with other presentations from science and technology. So you have the calendar. You can see the website where you can find a lot of information there. So if you want to have more information, you probably received it by email, or if you didn't, then you can just search it on our website, okay? Let me give you a little bit of an idea of how it's going to be working. Every team has 20 minutes for their complete presentation. That means that 15 minutes, maximum 15 minutes is for presenting your results, and 5 minutes maximum for questions and answers, okay? So it's quite dynamic. It's very fast, right? It's very fast, 20 minutes per team. Be sure to be well organized, to have everything prepared to, there's only one microphone, so you're going to be passing the microphone between the team members. So try to be agile with the transitions, please. We also have, every presentation is going to be also somehow evaluated, okay? We have a nice long list of judges, of people that we have invited from industry, from other research centers, from universities, from partners from the university, and we are going to be, I'm part of them, we're going to be judging you, we're going to be checking the quality of your presentation. There are going to be 5 elements that we're going to be checking in your presentation, 5 elements. The first element has to do with how you present as a team. How did you contribute it to the project? How you shared the responsibilities of the development of the project. The second one has to do with your your ideas, how innovative your ideas are, how the creativity that you put in your projects, okay? The third element has to do with your methods, with how you developed your project. How did you carry out all of your experiments and your design processes and so on? The fourth one has to do with your results, your conclusions. What did your outcome? What are your outcomes? What did your project tells you? What can you benefit out of what you have done, right? And the last element, the fifth element, is about how you are able to present clearly your ideas. So it has to do more with your oral abilities. Okay, so those 5 elements we're going to be checking from everybody, and there will be per area. There will be some little certificate for those who are achieving the best, the best ideas, to showing the best results and so on. We're going to be grading that via online. So there are some QRs that you can scan so that you can go into the evaluation website. Okay, that's for the judges, right? So we have several judges online and some here. So just for you to know. So each team has its own QR, right? So scan it for each one. And don't forget to press submit at the end. You're going to be grading from 0 to 10, being 0 the least and 10 the maximum. So very in the Mexican scale, right? Okay, so again, we have 5 presentations today. We'll start with the first one in a minute or 2. And I just want to, again, welcome you to the Create at CQ-AState 2022. Comments, questions? Everything clear? Okay, so then you're going to present the first. Yeah.
Okay, guys, so as Dr. Posani said, thank you guys for being here. Today we're going to start off our CQ-AState with a presentation of marketing titled Gender Violence in Mexico Throughout the Last Decade, and it's going to be presented by Jaime Ordaz.
Over here, all yours. If you have a problem.
Thank you. Hello, everyone. As the introducer said, my name is Jaime Ordaz, and I'm going to be talking about gender violence in Mexico throughout the last decade. These types of projects should be talked about because it's a concern that has been going on over a lot of generations, past and present ones, and it's causing a lot of issues in our current society. It's a passionate project to me because not only as a woman that was raised in Mexico, but also as a project that I believe needs to be going on forward. And also this is also kind of a personal thing because I lost 2 dear friends due to this type of issues. So the reason why I'm doing this research is because, as mentioned previously, this was a top subject mostly spoken in generations as a forbidden subject. Talking about our great-grandparents' generations or great-parents' generations, this subject wasn't even spoken of. This was a private matter that happened at each household. Nobody dared to talk about it because they believed they were family problems. As generations move forward, for our fathers, for our parents, and even for some of our grandparents, these conversations began to be more open, but still kind of private, still on the shush version. As long as nobody else got involved, this wasn't such an important matter. Now, for our generation and for our future children generations, these subjects have been more obvious. It is much more difficult to hide this. With social media and a lot of things on the internet, it's very hard not to talk about these type of objects. So this is why the main objective of this research is to inform younger artists about this. Also, another purpose on this research is to find a relation between economic and political instability and gender-biased crimes. We live in a country that tends to have a lot of flaws in its infrastructure, in the government and on the economical area. Sometimes it is believed that when certain political parties were in reigning governments, those were the moments where the highest levels of crimes happened. So we're trying to find if there's a relation between them. For the next, I just mentioned why I'm doing this research, but here is why this type of research will be done. In Mexico, over 10 feminicides happen each year, as well as 7 from 10 women suffer any sort of violence. By violence, we mean psychological, emotional, physical, and even sexual abuse. And in 2020, 5 women were missing every day for a year, and none of them have been found. If we do the math, that means it's around 1,800 women that have not been found. The graph above shows also the numbers of feminicides happened from 2015 to 2019. By femicide, I mean the term for the homicide that targets women based on their genders. And as we can see, this graph, the numbers start escalating. And if we also do the math, if there's 365 days a year, or we have numbers from 400 to 1,000, that means more than 1 feminicide happens a day. And as mentioned previously, this is very vulnerable for younger generations because they can see everything online. They're getting used to seeing this type of news. They're getting used to seeing this type of behaviors, and that is not normal. This is not something we have to learn how to live with. We have to stop this, and this is why this research is very important, because not only should we find a way to stop it, we should also inform younger generations. Now, talking about my project, my research, I did 2 rounds of my survey. I first focused on both females and males between the ages of 18 to 70, and with different political parties. And it was done entirely in Mexico, but I had most answers from the Estado de Mexico, Oaxaca, Quintana Roo, and Querétaro. I got 329 people to answer this survey, and I got a lot of feedback from the first survey. A lot of people didn't want to answer my survey when they got to question number 5 and 6, because it talked about their political views and their preference to certain political parties. Many people feared that if they talked about a political party, they were going to suffer some consequences. And I had to reassure them that this was done entirely for school purposes. It was not done for governmental purposes, but many people were scared of that. So when I did my second run of the survey, I excluded those questions of political parties and political views, and mostly focused on type of their personal beliefs on gender violence and political stability, economical stability in Mexico. And I got a sample of 358 people. So here I have my first round. I have some cross tables referring to some questions that particularly caught my eye, which were the relation between how gender felt that the domestic security in Mexico was over the last decade, and also how many people have suffered any sort of violence in both genders. And what I found was that despite what I believed and was my full hypothesis, was that women suffer more in terms of violence, which is obvious, which is something that we kind of believe, but also men suffer a very kind of violence. When I asked what type of violence they would have suffered, I just didn't put robberies or sexual harassment. I also put kidnappings, sexual molestations, and sort of topics like that. So when I did my second run, I found that still a lot of people, mostly women, suffer a lot of violence, but also men still suffer this type of violence. And what I can deduct from this is that, yes, it might be particularly for the gender, but also that doesn't mean that women are the only targets of facing violence in Mexico. Yes, this presentation, this research is focusing on gender violence, but also we should not exclude the other gender, because many people believe that us women suffer are easier targets because of our gender, because of our physical ability, because of physical capabilities. But this shows that not only us are targets, it's also men. And now for when I conducted my Soma Nova tests, I first rejected my null hypothesis because I didn't believe it was relevant statistically speaking. But when I conducted my second ANOVA, I had to eliminate two variables, which were very important for my first run, which was relationship between insecurity and economic stability, and relation between crime and government. Since people were fearful of the possible outcomes of responding those questions, I had to delete those questions, leaving me without more variables to conduct an ANOVA test that could give me similar or kind of similar results. And despite the fact that my new ANOVA test rejects my null hypothesis, I still believe that it's not as accurate as I would have liked it in the first ANOVA test that I conducted. And that's something that I concluded from my test runs from the research that I did over these past months. And so the conclusion that I take from this is that we can make an overall assumption on gender violence, specifically on gender. We need to look at more details. I just asked some basic questions, but I believe there is much more in depth for that. As well, it is very balanced, the amount of violence that women and men feel, although more women are more potential targets than men. And at the same time, I only got 0.0004% of the total Mexico population to answer my survey. It is not that statistically relevant, but it's still a fair amount of numbers, being that we're 120 million population country. And something that I take away from this presentation and this research that I did is that we're a big country, which means that we need more people to answer these type of questions to know. I can just say what I got from 358 people, but if I got at least the 0.0010% of the population to answer this, we'll get a much more higher result over how people feel over gender violence and political stability. At the same time, we need to stop having fear of the government. Some of these research we do are just for educational purposes. It's not to target or be against our governments. So we should be more open to answer these type of questions, and people should stop being fearful over that. And also, something very important for this presentation is being able to inform younger audiences and be able to provide them that information that they really need. Because what they see online is not something they should take on personally. Thank you. Are there any questions?
Yeah, I actually have one. Look, you needed to take out some of those two questions there. Which one were the results? Those questions in the first one.
A lot of people believe that there was a relation between political instability and crime, but I only got from those questions, I only got 115 people to respond that. I had more than the 50% that didn't responding that. And I think that if more people would have, if I would have left these questions, I don't know if maybe more people would have answered. I would like to believe that they would have answered it. But at the same time, I decided to exclude it because it made a lot of people uncomfortable to ask that side of question. And I understand that because there's a lot of non-security in the government. There's a lot of trust in our government. So even if I'm like reassuring them that this is just for educational purposes, they can still feel that it can be potentially like harm them. So I would like to say that this type of question might have actually been impactful for my current, my second run of survey. And I believe that it would have been more impactful. Yes. Personally, I do believe so. I think that a lot of people suffer violence based on their gender because, as mentioned before, us women, we're looked at as easier targets, more vulnerable targets, because people believe us do not put up so much of a fight. But from what I could look at, I saw that, yes, a lot of women faced violence, but some of the violence they faced was more psychological harassment from their partners or their friends or even the family members. So depending on what type of violence we're referring to, maybe femicides or psychological abuse, we can deduct if there's more of a gender term in that, which I would like to maybe test on the future.
Maybe we ask some questions in the audience in Zoom.
Oh, yeah. I gave the survey to my aunts and they send it all to their friends. And as I got my results from SPSS and I do like some correlations and cross tables, I found out that I had one person from Chihuahua answer, as well I had 2 people from Veracruz, and I had around 50 people from Quintana Roo, 40 people from Querétaro, 80 people in Oaxaca. And my bigger numbers were in those states, which is why I say that specifically I got more results in those states. But in the second round, I got a fair amount of answers from the 32 states here in Mexico, which is why I dare to say that I kind of had like a general census on each of the states in Mexico. Sorry? Yeah, most of us we don't know who here among our students members, like we don't know who are more particular of a political party. We don't know if their families are from the government. And sometimes between like chit chats, a lot of things can be said and a lot of comments can be said also that can kind of trigger the government. We can take, for example, the movement of Tlatelolco in '68. A lot of people still had that fear of talking negatively over the government and being disappeared the next day, being taken away and being murdered. So it's something that kind of stayed since '68, since has only been 50 years since that happened. So I think we should start being more open to talk about the government, because we have to understand that a government has flaws. There's not a perfect government. Every government has flaws. So we should stop being fearful of those consequences and start talking, because the more feedback there is, the better the government can make adjustments, can make changes, and that can benefit us and also can benefit them.
Do you have any questions from Zoom? Any doubts?
Thank you so much.
Right. So thank you so much for such an amazing presentation. The next presentation comes from the Department of Mechanical Engineering. It is titled Christmas Tree Fastener Analysis. Our presenters are, oh no, sorry, wrong presentation. It does come from Mechanical Engineering. And our presenters are Leslie Rack, Fania Hernandez Romero, Armando Ortega, and Jorge Ayala. Please to come to the front.
Thank you. Should stand over here. Yep. Is it like a clip or something? Yeah. There you go. Just like this. It's kind of difficult. Yeah. Yeah, hello. Good afternoon. Thank you very much, everyone, for being here. We're pretty excited to talk to you today. My name is Jorge Ayala. My thesis partner is Leslie Hernandez and Armando Ortega. We are going to present to you today about our senior design project that we've been working on for the last a year. And it's about the analysis of Christmas tree fastener. All right, first to start, this project was first brought to us by Brose, which is an international company of automotive parts supplier, one of the most important in the whole world. The main problem was basically in the lower section of seat of automotive seat. More specifically, it was in the rail system. There was a problem with a fastener that was a defective one. And basically, we need to evaluate the situation and to come up with reliable solutions. First, we thought about taking out by replacing the fastener, but by taking out completely out of the system. Also, we thought about repairing the existing screw. And the final one was just to create a new one, a brand new design, a brand new screw that basically fits perfectly in the whole system, in the whole rail system. For this, we based our design in functionality, in efficiency, in cost production, in feasibility, and many other topics as well. And the final part of our project was to live create the final designs, the final proposals, and for us to physically see how our final designs will look like, and see if they are going to work or not in the designated system. We base our whole investigation mainly in three main parts, into three main topics of interest, if you may. The design of the fastener. It should be reliable, it should work, it should be added perfectly to the existing rail system. Also the material, that was kind of a big topic right there, because we needed to look for a new material. The existing defective fastener was made of steel, so we decided to change a little bit that material as well. And also testing. We did several testing analysis, the force analysis. We did several AFE analysis for us to determine if our design was compliant, was following the several requirements and specifications that our project has.
Okay, so, well, as we know, many manufacturers are still working to improve the reduction of fuel efficiency or fuel consumption. So basically our project, the main scope is to reduce weight and also cost. And our project is based on a Mercedes-Benz SUV, in which we are mainly focusing on the 40% seat, which is the single seat that is located at the second row. And for the material, we are using Ultramid A4H. At the beginning, we were using Celestron, but we realized that Ultramid was less dense, so that's why we chose to continue using Ultramid. And also because it has like unique properties. For example, it has high mechanical strength. Also, it's very high stiffness. Also has high stability and, well, thermal stability. And most importantly, it has it's resistant to high stresses. And this is very important for us because, as we know, it's located in the seat, so the car is going to be always moving, and we need to consider all these factors, as my partner already said, which can be vibrations and also thermal reactions and all that stuff. That's why we continue using Ultramid. And then for the technical feasibilities, well, as I already said, we are focusing mainly, or our main goal is to reduce weight and cost. And also this needs to be feasible to our customers. And well, we are modifying the subassembly that connects the motor with the link adjusted motor by replacing the metal screw with a plastic screw. The link adjusted motor is the metal part, which is the gray part, and the other one is the motor cutter. So our fastener is going to be held by both parts. And also we need to take into account security, because this is something really important that we need to consider every time we do a project or we are doing a design, and also will decrease the minor logistics costs.
Apologies about the little delay. I had a little issue that I had to handle, but I'm good now. So we had thought about 3 different proposals. The first one was just on the rod holder, the motor holder, was just to have where that orange piece is, just an extension to it. So in fact, what we were planning on doing is in fact removing the screw whatsoever. We thought about it, and we realized that it was actually a really difficult decision, because then we would have to machine that part differently, and so we would have to have a different form of way of making it, and overall it was a big tooling cost, and so we completely neglected this idea. So what we then came up with were these 2 fasteners. The first one which we had named as an edge fastener, and the last one as a tree fastener. The design of these 2 were very similar to what the original screw was, or the original fastener was. All that we had taken into account was just removing some of the material, so that way the screw would be lighter, less material, a little bit more into the manufacturing, but overall it would be less material that would cover the exact same requirements that piece would be needing. Here, like we had said, this was the rough idea of what we wanted to do, but in the end, we didn't like it. It was a lot of tooling, a lot of manufacturing, a lot of changing a bunch of things, and we didn't like the concept of it. This is roughly the first screw, which was the tree screw. This would be the dimensions that we had created, that we had made. Again, very similar to the original screw. All that was done was created these ridges at the bottom, or sorry, at the lead of the screw, so that way we can see how this screw would end up getting rid of some of the weight. Let's continue. Here we're going to take a look at the forces that are being applied. We had roughly estimated that an average crash goes around, I believe, around 50 kilometers an hour to about, or 50 miles per hour. We had translated that into newtons, and so we had considered this as the impact on the side of the vehicle. And so roughly, if that were to be directly impacted onto the screw, this is more or less the deformation that we would see within the screw. But as we can see here, it's a little difficult to see, but it is about 187 at the very max megapascals, which is the unit of force over an area. So it's a shear. And on the other side, we can see roughly how much of the movement or the displacement that the screw would be receiving. As we can see, it's around 1.68, I believe, millimeters. And so it's minimal. It's really not moving whatsoever. And so when we take a look at these things, the force that is being applied and the rotation, the displacement that is actually being witnessed within these is actually really minimal. So it's withstanding an average crash that the vehicle would be receiving. The next one, we had taken into consideration a head-on collision. Roughly around the same, force was applied to this one as to the previous one, but because it was a head-on collision, we had assumed that the car and the seat would be doing a sort of pulling action. And so what we can see here is roughly around the same things. In fact, this was actually able to support a little bit more of the weight, about the force that was being applied, being less than 0.1 or roughly around 0.1 megapascals. And then the other side, it's minimal. It's absolutely not even moving whatsoever. And finally, this would be a little bit of a weird one, because we had applied a torsional force to this, a torsion to the screw. As for what kind of crash this would be caused by, I'm not exactly too sure. You would have to really screw up the car. But we had also taken it into consideration. Again, it's roughly around 40 megapascals, around the same force that we had put. In this case, obviously, because it's a torsion, it would be different calculations and everything, but we had more or less estimated the equivalencies around that. Again, 0.5-ish millimeters, it's really not moving. It's going to stay where it is. It has no problem withstanding an average crash that a vehicle would be experiencing at these forces. The next one, the fastener edge, roughly the same idea, but instead of having it like the Christmas tree idea, what we had taken into consideration would be a sort of push, a sort of like a fastener, or a sort of being able to hook onto the motor, plus the little the metallic edge. Yes, roughly. With this design, I believe it's a little bit heavier. It's got more volume to it, but it acts roughly around the same idea as the other tree fastener. Let's continue. Here, like we had said, this was the same forces were applied onto this one as to the previous one. Here, we're going to be able to see around about 15, I believe that it was about 130 newtons being applied in a transverse way. So that way we can see how the side of the impact would be affecting this one compared to the other one. I don't remember exactly right, but it was about 118 megapascals. So this one is in fact actually noticing a little bit more in terms of the pressure that is being applied onto it. And here in this case, it would be 3.14 millimeters that it would be displacing. A little bit more compared to the previous one. But again, 3 millimeters, very minimal. It's almost negligible. Please continue. This one, again, it would be the pressure that we would see in terms of a head-on collision. We're actually able to see here that the megapascals are actually withstanding a little bit more. The pressure is less than that of the other ones. Again, 0.2 millimeters is also very minimal. It's not, in fact, moving very much. Please. And again, the rotational portion of it, 21.3 megapascals. And what does that say? About 0.16 millimeters. Again, not moving very much. Like I had said previously, it's a little difficult to see how a rotational portion would be, other than the car would be flipped or some drastic accident would cause this form of deformation inside of the fastener.
Well, thank you very much. Well, as we just saw, basically both of the designs, they were pretty efficient. They were not huge differences among them. So now one of the most important part of the project was to make a final decision. So for the final selection, a pretty intense market research was performed. We compared the cost between the material ultramid and the price of the steel in the market, in the stock market nowadays. We compared them in density, in weight, and after making a deeper analysis into it, we got to the conclusion that the best design that complies with our requirements and the specifications of our investigation was design number 1. So proposal A, that is the threaded fastener. This was mainly because it is a little bit lighter, so the mass and the density of it is a little bit less compared to the edged one. So if we try, we would like to produce this in a mass production scale, in a bigger scale. So this will reduce the production cost automatically. So this will be pretty great for our customer. And here we get the printed ones. This is the original size of it, but we printed a little bit more in a bigger scale for you guys to see in a more detailed way our final designs. And we'll pass it to you for you guys to see. That will be basically the red one was the final selected proposal. That will be. Thank you very much for attention. If you guys have any questions, please feel free to address them. Yes, Doctor.
I do have a question, a couple of questions. The first one is, I see the tooling. So that means it's a normal screwdriver or a specific.
Yeah, it depends on the head of the screw. It's I don't know the name of it.
It's a
Is
little bit different.
yeah,
Like
it's
a start
the
time.
estrellado exactly.
Okay,
Yes, the
and the other
start.
one doesn't require any tooling?
No, it's just basically we just human
Human
pressure just with the
pressure.
finger. Yeah.
You might need a little bit of a tool that would cause the pressure, but it really doesn't need very much to push in. Maybe the repetitive process of a human being able to push it in, maybe would, not deform, sorry, would cause fatigue in the person being able to push it. So maybe a tooling would have to be considered. But because of the fact that we had decided on the threaded one, a little bit more research was done into that one than the edge.
Okay, and how was it before? So the previous, the metal one, the metal screw, how was it put placed before? Was it also simple with the hand?
No,
or
it was threaded.
It was a special tool. So you're also saving in the special tools, right?
It also was having in tooling and also in just in time.
In the time that you
Exactly.
require to
In
do
the
it.
installation process, will be take less time just to push it, for example.
Okay, and can you go back just to the last slide? Just what is exactly what it tells you that you are choosing A instead of B? What is the main thing?
Basically, it was just the weight of it. The density and the mass in the fastener to a little bit less. So it will require less material to produce. So we will be saving costs.
Okay.
If we're planning to produce it in a bigger scale and mass production scale, then there will be definitely saving a lot of production costs in there.
Okay, so it's costs.
Yeah.
Okay, thank you.
Yep.
Question for you. So it's really interesting that a large company has come to you to make this analysis. Just a suggestion, before you present the final solution, give us context, because some of us are not experts on automotive production methods and materials, etc. So it would be amazing for me to know a little bit more about what is the Christmas tree fastener,
Okay.
where is it going to be located, what is the main problem that you need to solve, etc. So we can better understand what is that you are trying to achieve, right?
Okay, just to focus on details and
Yeah,
background.
and
Okay.
then you move on to the how, to the when, to the etc. So you can give us more context. And a second suggestion for me would be to incorporate sustainability analysis. It would be really interesting for you to compare whether the metal screw would be better or plastic,
Okay.
or additive manufacturing or recycling products to be incorporated in the new fastener. So it would be really interesting to see this analysis, despite that you have already this material and density, diameter, then tooling. Also, the sustainability analysis would be really interesting.
Okay. Thank you very much.
So this item of is unique, right? It doesn't exist in the market.
Uh,
Correct, yes, it's not a catalog number.
You need to modify the part in which it will be inserted. What is it going to call this item? Just virtual item?
It would be, yes,
You have another
so,
one similar to.
so roughly, the previous fastener that we had a certain specific diameter that was predetermined, but because of the fact that we do want it to be caused or be inserted based on pressure and being able to hold its place based on a little bit of pressure, it was added less than a millimeter, around a millimeter in terms of.
So it is a post-fit system where it has webs that
Within the hole, within the piece that was done prior, would you be able to go back, I guess, to the third slide, I believe it was? That design was completely straight. A little bit further. There we go. This one was completely straight. And so inside of the hole, in fact, it's not even threaded whatsoever. So what we had taken the idea is just remove material. It may be a little bit, we would have to look into machining and tooling costs to be able to produce this part because of the fact that it is, like we had said, it's not a catalog number. In fact, it's a completely new number, a new part created. But yes, it would be a little bit further than the dimensions that is specified there at the bottom, the diameter, I mean.
very much. So you did an analysis for transfer loads.
Correct.
What about?
We had seen that one, which was the second version that we had saw, which was the head-on collision that I had mentioned.
What does it happen if it doesn't, if it gets loose, it doesn't break?
I see what you mean. The screw would like separate from the piece. I will be honest, I did not consider that at the moment, but a little of other analysis could be done to be able to consider that, how much pressure the the motor rod holder would need so that to be able to separate from the fastener.
It will be a difficult scenario, but we'll take a look into that one.
Yeah, because a lot of analysis can be done, for example, vibration, which is used to designing software. can play
Yes.
with that information.
Again, very overview, but to be able to go into more detail, we would have to put more time into it. But yes, I would agree. There would need to be a little bit more analysis in terms of safety and everything.
Right, so thank you very much.
Thank you.
Thank you guys for that presentation. So we will move on with another presentation of mechanical engineering that is titled Electrochemical Maneuvering Automobile. And it's going to be presented by Daniel Rosas, Uriel Gonzalez, Ana Ortega, Josué Diaz, and David Miranda. Please.
Guys, stay close to the center.
Well, good afternoon, everybody. Thank you for being here. We really appreciate your time. So we mechanical.
Please put it over here so the microphones.
Okay. Project. So the main objective of this one is to create an autonomous car that can be able to park itself. I don't know if you want to continue with the objectives. Sorry.
Yeah. So this is. So yeah, what we tried to do, or our objectives were to create a model of an autonomous car, obviously like very simplified. And the task we intended to do is parallel parking. And the part of the design included the support, the chassis of the car, and on the mechanical side, the traction and direction systems. For the electrical part, it included like the algorithms, the logic, the steps that the car would follow so it could park correctly, and embedding that or mixing that with the mechanical systems. And now we will see a little bit of the mechanical systems.
Okay, so first we based this model
in a Camaro V8 2021. And here in the right side, you can see some measurements of this car, such as the length, the width, and a very important one, the distance between the two axles. And we chose to use a scale of 1 to 10. So just to know the measurements of our car, you just need to move the decimal one place to the left. And the first thing we had to focus on was figuring out how to make the front wheel steer. And after looking at many steering systems, we decided that the Ackerman steering system would be the best fit for us. It consists of a long bar, which is centered in the wheel, so it's the axle, and then a smaller bar in the front or in the back, and it is linked with a link that fixes the wheels. So when you move the yellow bar, the wheels would turn from side to side. A very important thing in this geometry is that when you link the ends of these two bars, where they meet in the back, must be the center of the back axle.
Thank you, Anna. So once the steering geometry was decided, in this case, the Ackerman geometry, it was time to do some proper calculations in order to determine the correct measurement of this geometry, okay? So how did we make this? Well, first of all, we took the complete car. We decided to take the whole measurements, and just by dividing it at half, we are going to apply just simple geometry in order to determine the angles, okay? To determine the angles, it is necessary in order to, well, in this case, beta and alpha, in order now to move to the Ackerman geometry, because it has the shape of a trapeze. In order to apply, again, geometry and determine the correct measurements, we are going to make a diagonal line in order to divide it in half, and now we are going to have a right triangle. And with similarity of triangles, we can use the angles that we previously calculated here. And then using the law of sines, we are going to determine the rest of measurements. We are not going to emphasize a lot in the calculations, but if you want like a full explanation on that, you can ask for our paper in which we specifically explain the numbers and all that stuff. So please, next slide. Okay. Okay. So now that we calculated the measurements, it was time for designing the parts, okay? So we designed 5 parts. Every part was designed in solid edge. As you might be able to see in this photo, the one of the bottom, we have the big plate. Each, well, important to remark, each piece was designed in order for the servo motor to work properly, because the servo is the one which will move this steering system. So we have the big plate, which, as you might be able to see, it has the space in order to hold the servo motor. We have those circles, which are going to be the spaces in which the chassis is going to be connected, okay? And then we have the wheels, okay? The wheels, I think, is one of the most attractive parts of the design that we made, because it passed through several prototypes. So yeah, as you might be able to, well, if you want to take a deeper look, feel free to do.
Well, now the next part is the small bar, which is part of the Ackerman geometry that we explained before. And it will move from side to side to make the wheels turn. And that part over there on the top is the one that will connect the servo here with this bar. So it will move, it will translate the movement of the servo to the small part. And the link, which will be here, and it connects the, well, these 2 parts, and the wheel, the circular hole over there, it will have a rod, and then we connected the wheel, so it will have free movement.
For the change of mic. So now that the parts were properly designed, it was time for printing. As you may see in the def image, we have the first prototype of the steering system, okay? This is a very simple steering system without the chassis and without the transmission. As you might be able to see here, we are using even a smaller servo. The wheels don't have a proper design. That's what I was talking about. The wheels pass through several modifications. And it was being fixed with screws that, okay, it hold them in place, but it was compromising the rotation of the parts, okay? So now that we make all those observations, we could be able to make the proper modifications in the next image, which is now the good steering geometry, okay? Because, well, it now holds a bigger servo. So by being a bigger servo, it has more power in order to move the steering system. We have the redesign of the wheels, which are bigger, which have a new complete design in order to make it more like aerodynamic. Well, that they can present like a little bit more of friction in order that it can properly move. And now the pieces are being fixed by some axles that we designed. That now they can be fixed in place without compromising the rotation of the pieces. And now we moved with the chassis of the car. So by the chassis, we use the parts of Tetris Pitsco because, well, we thought that it was the ideal pieces to use because it added some weight to the steering system in order that it could move properly, and also because it has like the specifications to connect not just to connect the steering system with the transmission system.
And finally, for the final part of the mechanical design, the transmission. It consists of this motor with an internal encoder and two gears. One gear is connected to the motor and another one on the axle. It's important to say that our car has a back transmission, so the transmission is on the back. And for simplicity, and since we don't need the car to go at such high speeds, we decided that we would just use a 1:1 gear ratio of 1. So 1 revolution of the motor translates into 1 revolution of the wheels.
Well, now for the electrical design, the first thing we decided was the components of EMA. And the first one is a sonar that this actually gives us the lateral distance to EMA. The motor, the DC motor that allows us to go forward, to move. And this motor, it has an encoder built in. So the encoder, the thing that gives us is the possibility to know the position of EMA in time. The servo motor that controls the steering mechanism. The Arduino, that it's basically the brain of EMA, that it's the one that controls all the other parts and do the calculation needed. And H-bridge that allows to control the direction of EMA, if it's going forwards or backwards, and also its hertz speed. And finally, a battery that it gives energy to the whole system, so it can do all the things we want to. So now we'll go through the algorithm.
So for the algorithm, we decided to divide it in these 4 sections. So the first one is calibration and starting position. Here we receive the first input from the sonar to kind of know where we're at in terms of the lateral distance between EMA and the first part vehicle. And just to start moving forward, then there's spot finding. In this section, the algorithm is reading the input from the sonar and the encoder to know kind of how big the spot is. So it knows if it can fit or not. Then if it can fit, it goes to the next section, which is the parking spot. Here we can calculate again how far apart we are from the second vehicle.
and how big is the spot to do the following equations and park correctly. And finally, the final adjustment, which Emma just kind of repositions itself inside the parking spot and ends the program. So the next one here is the constraint for the algorithm. So there we have these 4 constraints. So the first one is there must be at least 2 vehicles for spot recognition. The parked vehicles need to be parallel to Emma and to each other. Emma must start beside and a reasonable proximity to the first parked vehicle, and no change in the surroundings once the parking maneuver begins. So we have these constraints because what we just wanted to do was to do the autonomous parking. If we take away some of these constraints, we need to add more sensors, and that would actually involve doing different autonomous tasks that are apart from just parking. It would be things such as object recognition and obstacles. So now for the actual algorithm, we have these. Can you go to the next one? Here we have the logic of the first step. So first, when it starts, it scans the initial distance. So you have the sonar right at the side of Emma. So it checks where it is in respect to the first parked vehicle. It starts moving forward. The encoder starts working, so it starts recording how much has Emma traveled according to how much revolutions the motor has made. And so you start scanning the lateral distance to find a gap. This gap, I mean the lateral distance. So not much as the spot, how long it is, but how wide it is. So if there's a gap, so the car can fit in that gap, then it enters this loop when you start recording that how much has it been since that first gap. And now that you scan that, you see, you start recording and you see if the gap continues. So if the gap is still there, and you see if the car fits based comparing how much has it traveled. So with the travel distance, you compare that to the minimum distance that we have set that Emma can park between that. And and if if it fits, then it just starts the parking algorithm. So it starts to calculate how much does it need to move to park. And if it doesn't, then it starts again looking for a gap, and the process repeats. Now for the next.
So once Emma has gathered all the required information, it goes into making the calculations for it to fit into the space, which are the first 4 block diagrams, the first 4 blocks. And there we get the information of how long it has to travel, what are the arc lengths of that Emma has to do. And once it has the necessary information, it actually goes into the parking, into moving the car and moving the wheels and so on. And at the end, it just, as David said earlier, it just adjusts itself into the parking, into the spot. Okay. Yeah, we just wanted to show you a quick video, which, yeah, here is actually the system working. First, as you can see, it can scan, it moves, it finds, well, it is scanning for a spot. Then once it reaches to the object in front or to the car in front, it starts the parking maneuver. And just adjusts at the end. Yeah, so I don't think we have time to see the other video, but this algorithm actually accounts for different for changes in the space between the cars. So it's not the same maneuver always. So it kind of thinks or makes calculations for it to fit into the different scenarios. It's constrained still, but yeah, it can work.
So there the distance is a little bit closer. So the car is going to move a little bit. It's going to reposition more forward and
It's not doing the same thing over and over. It's actually taking the input from the encoder and the sensor to do. Thank you.
Congratulations, guys. Why did you correlate the vehicle fatalities and traffic crashes with parking? How is it related?
Well, at first it was that there are more fatalities when because the correlation was that humans create those factors, right? And yeah, even though we are thinking, yeah,
It's like a, oh, yes. This is just like a beginning, but we wanted like to introduce first like autonomous parking and start introducing that maybe the autonomous machines can prevent in a future more fatalities or more accidents.
So the motor mix which direction?
Right, so for the steering, it's a servo motor. So you actually put how many degrees you want it to move. So it's actually very simple to manipulate. You just tell it where at what position you want it, and that's it. Yeah, the left and right. Well, the range is from 0 degrees to 180, so it's just half the circle. So we put it kind of in the middle, and then we just let's say we set it at 90, and then if we want 15 degrees to the right, we say 105. And the Arduino, the board, we code into the board, and the board just send the code to the that one.
So we just in this time because it's only parking, we just decided to keep the same speed. So we were actually setting just so it could be nice to see in the serial print just what was kind of going on, how the readings from the sonar, and also that well, it was gradual and not too fast, so we could see what was happening. But it really is just the same speed. We just set it. Oh yeah, you know, we just sent a PWM signal, so we just kind of, that's why we use the edge reach, just to kind of have that.
But we're out of time. Thank you guys so much.
So yet again, thank you for such an amazing presentation and such an interesting project. Our next project, and actually almost our last project, it's also from the Department of Electrical Engineering, specifically speaking. Our presenters are Alejandra Melo Gomez and Armando Ortega. The title of the project is The Robotic Arm. So please come in front.
Well, hello everyone. Thank you for joining us today in this event. My name is Alexandra Melo. I'm joined with Armando Ortega, and this is our project, our robotic arm, a project for the class of robotics laboratory. Well, robots were created with an initial purpose, specifically talking about robotic arms to substitute a human arm, trying to do a tedious, repetitive, and maybe even dangerous task in industry. A robotic arm, what it does is it grabs a cube, places the cube on the color sensor, measures the color, and according to the measurement, it makes a decision of where to place the cube, in which basket.
To add a little bit to what she had mentioned is that this robot is meant to, like she had mentioned, that this robot is meant to replace a human ability, right? But we had also modeled it on the idea of a robot from the 20th century, and where the robots of the 20th century are mostly made to be repetitive tasks, putting blocks from one point to another point, or maybe even switching screws, something repetitive that a robot is easily able to be programmed to be able to do thousands, if not hundreds of thousands of times. So that was the idea of the robot. How we managed to be able to do this is that we set it up so that way it is then controlled to be, it's able to have three degrees of freedom. The first one, which we named as the elbow, which is the portion at the bottom, is controlled by this servo. The servo, what it is very similar to a motor, but instead of a motor being defined based on revolutions per minute or revolutions per second or revolutions in general, the servo motor is designed so it goes based on positions. These motors, I believe, go from 0 to 180 degrees, or from 0 to 200 degrees, which is roughly around half a rotation or a little bit past half a rotation, which in our case, this is more than enough, because we're going to be seeing a video in how the robot is actually being able to move from specific points of the specific locations based on where the robot needs to be. The next servo, which would be considered as the elbow servo, will be controlling what the name very clearly defines, the elbow, which is focusing on moving the robot's arm up and down, being able to pick up the block, move upwards so that way it avoids any obstacle, go to the location based on the elbow, and then drop it down using the same servo. Finally, the last servo motor, which is located here on the forearm of the robot, will control the grip, in fact, the claw of the robot. The claw of the robot was actually 3D printed. This design was one of, I believe, 3 or 4 that we had decided on. The reason that we had decided on this one is that the moment, because the blocks have 4 edges, we had decided that this would probably be the best idea of being able to grab onto four of the edges, or having 4 points of contact versus a flat plane, a line, or 2 points on each side. 4 points of being able to grab onto is a much easier, much safer way of making sure that the block wouldn't fall, or that the block would make sure that it would get to the point where it needs to be.
Well, the color sensor, color detector, is this box with design, and it has inside a 3-color LED, fluorescent resistor, and a black wall that separates both. Once the robot places the cube on the color sensor, trying to cover the hole as much as possible, so the light of the surroundings of the room doesn't affect the measurement of the fluorescent resistor, what it will do is to turn on the LED. It will give red, green, and blue light, and at the same time, the fluorescent resistor will measure the light reflective on the surface of the cube that comes from the LED. The fluorescent resistor will measure. It will be stored for each color, the value of the fluorescent resistor, and it will make a decision on which is the highest value for which color. And then once it decides which color it is, it will place it on the correct basket. And this is due to the fact that any object of any color, when we put some light, it will reflect the part of the light spectrum that is the same color as the color of the object. The other part of the light spectrum will be absorbed by the object. So when we, for example, have the red cube and we turn on the LED, the light reflected on the cube will be much brighter for the red light than for the green and the blue light.
Continuing on to the mechanical portion of it, we're going to be looking into the gear system. The gear system, what we had decided on was, instead of adding torque or instead of adding speed in where we really don't need that, we decided to make a gear system, and so that way the servo doesn't actually have to be placed underneath of the elbow, or sorry, the tricep, the shoulder. Thank you so much. Instead of it being placed inside of the shoulder and having to carry all of the weight of the arm, it's actually in fact placed over here on this left side. So that way, all it has to do is just rotate the arm. The entire weight of the arm is being placed and held up by this portion down here, which is a lot easier for the axle to be able to support. And in fact, actually, these axles that are within here are not supporting any weight. They're not holding up anything. All they're doing there is just making sure that the gears are maintained in place. As for how they're maintained exactly in place, these portions here and in the back are to make sure that the gears would not separate. We were seeing a couple issues in where it was actually twisting a little bit too far, or twisting not far enough, and so the gears would end up skipping. Placing these beams, I would call them, completely fixed the issue. We have no problem in terms of the shoulder anymore. The last portion of here, which would be the elbow joint, because of the fact that most of the weight is in fact being carried onto that elbow, or the elbow is experiencing the most amount of force being applied onto it, we wanted to make sure that it wasn't going to be experiencing any sort of vibrations or any sort of maladies within it. And so it might seem a little bit excessive, but we made sure that we added enough screws so that way it would be able to hold its place, hold the force that is the forearm plus the grip without any problem, which is that portion there at the bottom. Please continue.
And for the brain of a robot, we use an Arduino. We first declare the variables, the position of each servo. We prefer to have them as variables because we will be telling the servo to move to the same position over and over again repetitively. And once we declare our variables, we go to the void setup, which is executed only once. Then the void loop, which will be following the same path over and over. We have some delay time for the servos to move from the initial position to the desired position. And we declared the 3 servos, each with the name of the part of the human arm we were trying to simulate. The shoulder, the elbow, and in this case, the grip, the wrist. Then for the part of the code to check the color, we turn on the red light first. We tell the photoresistor to measure the brightness of the light that is reflected on the cube, and it stores the value. It prints the value, and we do exactly the same for the green and the blue color. Once we have the values for the 3 colors, we have an else if statement that says that depending on the highest value, the shoulder will move to a certain position according to where we want to place the cube on which basket.
Oh, there we go. Well, unfortunately, I don't believe we're going to be able to see the video, but luckily we do have the machine here, so we are able to actually see it physically working. Would you be able to help us with plugging it in, Alex? Cute. So here we have the demonstration of how the cube is working. Here she had placed the green block. Once the green block was picked up, it is then able to go to the location where the sensor is. The sensor then flashes the red, blue, green lights, depending on which one is not absorbed, which in this case would be the green one. It would then detect it, then pick it up, and then place it where it should be, the green one, which should be at the far back right one. Then she would then place a separate color. In this case, she places the red one. The robot then is able to go to the same location, repeat the process, grab the red block, go over to the sensor, place the red block, flash the red, blue, and green light, depending on which one was reflected the best. Then it is able to then pick up that same block, detect that it was red, and place it onto the red portion of the machine. Finally, to repeat the process one last time, the blue one is then being placed. Again, the process repeats. We're able to see it pick up the block, place it on top of the sensor, drop it. The sensor then flashes the red, blue, and green light, depending on the blue one. I guess in this case, it would be the blue one that would be reflected the most. It is then able to detect that color, go over to the blue section, and place it down. And that would be our robot. Please, is there any questions? Yes, because of the fact that this is a representative of a 20th century robot, it is meant to be able to repeat the process an infinite amount of times. So yes, the robot is programmed to be able to only be only able to go to the same position, go down, grab the block, if there is a block, and then go over to continue on the process. So yes, the block has to be in the exact same position every time. We had that. It will continue. Please.
I will repeat the same process. It won't detect that there is no cube there. It will try to grab a block, a cube, although it won't grab anything, and it will go to the color sensor, and usually it goes then to the red color, the red basket.
Yes, actually, in fact, the design of the robot is only meant to, well, currently right now, because of the fact that the robot is actually meant to grab the block, detect it, and then place it where it needs to be. But because of the fact that these are servos and the Arduino program is actually really easy to program, we are able to then change it up so that way it in fact actually would be able to grab, I don't know, a little ball, or maybe change it up so that way it actually grabs something else, places it into a different place, maybe a different type of sorter. It's in fact this is a base design, so that way it could then be used in multiple different areas, multiple different functionalities. So there is no problem with switching its function right now. And in fact, it's just a baseline, so that way we can see how the robot is actually being able to use back in the 20th century. Very similar to, oh, would you mind turning off the sound, please? Yes, no sound. Thank you so much. I was laughing while the video was going. Yes, what's up? Time is money. Correct. In fact, actually, one other application that we were thinking of, although it would be a little bit more complicated, would be to have the sensor onto the grip itself. So that way, while it's moving, it is then able to detect the sensor. But because of simplicity's sake, we had decided that it would be easier just to place the block, have it completely covered have the sensor completely covered in darkness. So that way there is no fault in the color. So that's why we had decided on this here. Actually, continuing to, I want to go back to the question that Bayardo has said about the block being placed in a specific location. We had thought about having a sort of feeder or a form of a feeder, so that way the block could then we don't have to have any form of human interaction. In fact, it is completely 100% autonomous. Unfortunately, based on how the grip is made, as you can see, it's very static, and so the block is actually a little difficult to be able to grab it from a different location. With the grip being a little bit static, if we were to change the location or increase the height the grip would in fact actually miss it. So we would have to then either design the claw in a different way, or in fact have to add a different degree of freedom so that way the claw is able to rotate around the wrist, I guess. But as of right now, it does need a little bit of human interaction, but it serves its purpose. Any other questions?
We will have to modify the code so it will not only be like red, green, and blue, but more colors. Red is easy. Okay. The flow resistor, well, actually we have some trouble for the green color. So maybe it will be a little difficult with only the flow resistor, because we had to adjust the brightness of the LED for the green color, because it didn't match exactly the color of the cube. So when it tried to measure the color of the green cube, it will give us very small values for green, and the values for red and the values for blue approaching almost the values for green. So it was very, there was a very high possibility for it to not measure it correctly. So maybe it will be not with a flow resistor.
Thank you so much.
Thank you, guys. Up next, we have our final presentation from electrical engineering. The title of this presentation is Improvement of Self-Locking Mechanism for Frontal Impact. And the presenters are going to be Jesus Hernandez, Jonathan Bayardo, Eduardo Cuesta, Arturo Pacheco, and Andrea Villanueva. Thank you.
Did Andrea join in Zoom?
Yes, I'm here.
Okay, we're not gonna see you, but we can hear you.
It's okay. Thank you.
Are we starting? Okay. All right, so what's good, everyone? I hope all you doing okay. So today we will present to you our final project for senior design. It is called Improvement of Self-Locking Mechanism for Frontal Impact. My name is Jonathan. I am the team captain, and my team is conformed by Jesus Arroyo, who is one of our researchers, Andrea Villanueva, who is not here with us, but is through Zoom. She's also one of our researchers. They're pretty good. They can get you any type of info. And we have also Eduardo Cuesta and Arturo Pacheco, who are our designers. Today, what we're going to show you is a little introduction about our project itself, the approach that we took towards solving our problem, and eventually we're going to show you our designs, the results, and well, we have the seed right here, so you can check it out. There are also some pictures for you to know which are the things that we're trying to change or modify. Well, hope you enjoy the presentation.
Thank you. So can you go to the next? So the problem statement was that the current mechanism is the one that is found here. The purpose of that mechanism is that in the event of a frontal impact, it will lock itself in its position and not allow the seat for further motion that could result in the injury of the passenger. But one of the problems that it has is that it is complex to manufacture, it's expensive to make the assembly, and also that it does not fully cover the safety requirements that well, that at least are expected. One of the main phenomena that occurs is something known as the submarine effect that will be explained later by one of my colleagues. One of the main expectations is that the change in the design will be, of course, easier to manufacture, easier to install, and cheaper, but that it will remain true to the motion that is expected by the client, both our client and the client of the client. And so, yes, and that it prevents the submarine effect to a greater degree, of course. Next, please. So the client of our client is BMW, and to have some statistics to show the importance of a system like this one, in 2018, around 350,000 vehicles of BMW were sold in the US. And also in the US, 5.25 million crashes occur per year. And from those, 37 people die. And from the year 2006 to 2017, 55% of the crashes of BMW involved frontal impact, hence the importance of a system like this one. Yes, can you continue, please?
Can you guys hear me?
Yes.
Yes, okay, perfect, thank you. So as my partner Jesus was explaining, there's something called submarine effect that undergoes when we have a frontal impact. And basically what happens is that the submarine effect undergoes when the motion happens and the human goes underneath the seatbelt. And this overall pressurizes the body and it causes deformation on it. And there are some injuries that have been caused by the submarine effect. As you can see from the image, there's a lady that is undergoing the seatbelt and having the submarine effect. And well, some of the most common injuries are strangulation, fractures, spinal cord injuries, traumatic brain injuries, amongst many others. It could even lead to death. So as Jesus said, we have to take care of this mechanism in order to ensure at the best degree as possible that we are able to give a result that is not going to result in a submarine effect. So in order to do this, we had to come up with some design feasibility and the approach in the designs. So what we did is that we took into account that our main goal was not to redesign the entire mechanism from scratch, but rather we decided to take a more conservative approach, if we can call it that way. And the first thought that we had was not to modify as many components as possible, since the current mechanism only needs a few tweaks to its geometry. So what we did is to analyze separately all of the switches and all together to determine what was the best combination of the switches. So as you guys can see from the seatbelt that is in front of you, and also from the images that I'm showing here, the client said that parts 1, 2, and 3 were to be modified, and 4 and 5 had to be eliminated. So these are the main elements that were analyzed, and they were analyzed under the following criteria, which is 3 questions. The first of them was, is it possible to adjust this part and have no negative consequences on the motion of the mechanism? 2, the other pieces follow adjustment. So basically, how are the
how are the other pieces adjusting to what we were trying to do? And finally, number 3, how little are these changes? Are they altering in some way that we wouldn't like them to do, or is it okay if we just keep them instead of replacing them? And well, basically the results of all of these questions determined the pieces that were needed to redesign and which ones should be left untouched. So as you can see from the first table, we have the rubric. And well, basically we analyze all of these components or pieces through this rubric. Number 3 was it's fully if the design fulfilled the criteria in the design question. 1 was the score for partially, and 0 for does not. So in table 2, we can have the piece evaluation under these questions, and we can see the overall score for these questions and the parts. So as you guys can see, the pieces 1, 2, and 5 obtained an overall score of 7. In the 3 and 4, an overall score of 5.
Okay, thank you, Andrea. Now we will explain our process in the design, how our design evolved and how we began. And you can see this through our different proposals to our clients. This is the first one where we went to the basics. The main objective for this proposal was to see the movement that we could change. One of the objectives that we had, as we mentioned before, was the similar movement in the seat. And so we examined 3 different types of movement. One using a spring, which you cannot really see clearly, is a spring. One with a piston, and one with a similar mechanism to the original design, which is simply using sliding pieces, which we will call a slider design. Under further examination, the main 2 designs using a piston and a spring were concluded to be too expensive and too complicated to properly install. And so we decided to focus exclusively on sliding components.
Thank you, Eduardo. Now this batch of proposals were also developed as a sequence where we were given feedback in between each proposal. So first, starting off with proposal B1, it focused on eliminating the parts required and modifying an existing part, in this case, the P-shaped piece, so that it does its job plus the self-locking mechanism's job. After the given feedback, we developed proposal B2, where spring is included. In this case, we induced unwanted vibrations. Therefore, B3 was created, where we substituted the spring for a solid link. The problem with this proposal was this same link that had an S type of geometry. I don't know if you can see that over here. That induced stress concentrators, but it did took into consideration the 3 positions the seat has to could undergo. That is the resting position here. Then at the moment of the crash, this link would rotate, arriving to this position. And if the seat back would have to be reclined, it would go all over to the final position. As for, thank you, Vallejo. As for the proposals C1, it aimed to handle the load of the crash statically, and only when the seat had to be reclined, the washer and the bolt had to do their job and make this a new link rotate around it. And finally, we arrived to the proposal C2, where all the feedback given previously was taken into account, And it would again, this link would move along the path when the seed needed to be reclined, so that its final position would be like this.
With that into consideration, we made some last proposals, which were required by the client, in which we examined the original design. This is the original piece, which you could see in the set. Simply cut it down, basically, cut down. That is the main objective of this proposal is to cut costs, but we still needed to revise the design in order to for the seat to withstand the force needed to basically to pass the necessary examination for the submarine effect. The next one.
All right, so we already explained to you all of our proposals, but you may think, why do we care, right? Like, why do I want to see all your proposals? So basically, we explained to you that just for us to come up with the conclusions of how are we going to eventually choose our design. Okay, so this is basically the rubric that we took into account. These are mainly criteria that our client gave us. So we're already considering what they want, which eventually, of course, we have a client, we're trying to fulfill their requirements, with their needs, their wants. So pretty much this table is based on what they wanted, okay? If we go to the next one, please. We can see the results for each of these proposals eventually end up giving you the result that the best proposal was the one that I gave you around, the kind of like the elephant shape, which is proposal C2. This proposal fulfills all the requirements that our client gave us in the best possible way, which is basically, even though we're kind of like at the same point in the cost of production, the time of production is going to be less. As you may see right there, you may think, okay, the geometry is not even complicated. Why do I care about this? Well, that was actually the entire point of this project, to simplify the geometry. And if we make it quicker to manufacture, then of course we're fulfilling already the client requirements, right? Then number of parts modified per site, it's only one. We would not be changing all of the things that our client already has in their stock. We're only doing one retrofit, right? Finally, stays true to the original seat movement. So basically what we have in here is, if the seat is completely reclined, with the new mechanism or the new component that we have would follow the same motion, or would it break? Would it interfere with some other part at any other point? So basically, that was one of the reasons why we had to maintain not only the same movement, but also try to keep the geometries as close as possible to the originals. Then we go to the reduces the submarine effect. As Andrea already explained to you, the submarine effect can bring you a lot of damage. It can even kill you, all right? So if we reduce the submarine effect, which ensures the safety of our clients, or well, actually of our users, our customers, then we are fulfilling what we wanted. Finally, addresses change of plane from top and bottom left support safely. So this is basically a term in which what we have right at the bottom at the self-lock mechanism does not coincide with the same plane as where it has the interface with the tube. So basically what we're doing right here is to increase the area of contact that we're gonna have in those 2 points. And now by increasing the area of contact, now I heard that he mentioned that probably we should get into more technical stuff just for everyone to understand. So now we already explained to you all the kind of like the technical stuff of the seat itself. But now if we go straight into mechanical engineering, okay, if we increase the area, then if we increase the area, then we're going to decrease the stress that we have. The shear is going to be less. Therefore, our component is going to be able to withstand many more loads, right? As well as something that you may think is fatigue. Okay, so a person is going to be sitting, is going to be getting up, you know, sit down, sit up, whatever. And then, of course, our part is going to suffer from fatigue. However, the original geometry, they already have their calculations of fatigue for the original geometry. And pretty much what we have is that since we're using pretty much the same conditions in terms of manufacturing processes, we're doing the same processes, we're utilizing the same materials, and if we go into Goodman theory and try to calculate the endurance limit, which is basically for us to know the fatigue, the only actual factor that we're modifying is the geometry. And since we're increasing the area, we know that the fatigue is going to be around the same. You know, I mean, it could be even larger. So we're actually ensuring that the life of this new component is going to be around the same of the original geometry. So that would be the end of our presentation. If you have any questions, please let us know. And thank you for your attention. Oh, yeah, no, these seats have, look, these seats have the original self-locking mechanism. So pretty much what it does in here is once it goes down, this mechanism that is right below is going to lock itself. But then what happens is that what they call it in industry is the mechanism gets beat up. So basically it does not completely break, but kind of like deforms, and that's what causes the submarine effect in this seat. This is not already there. For us to actually implement or place our geometries into this seat, we would need stuff that we do not have access to. But what we're trying to do is with the pieces that I showed you around with the 3D print, we're going to print out the rest of the things that we designed. And finally, with glass fiber, we're going to do kind of like a similar geometry to the seat just to represent it and demonstrate that it actually has the same type of motion and that it actually withstands the loads. Yes, ma'am. Yes. 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 Well, five is actually the tube that's in there. Eventually, we spoke with our client and they told us that with the proposal that we have, we can leave it out. But what we actually changed was we got rid of the entire self-lock mechanism. This is the self-lock mechanism, the one with the ears and kind of like the base right in the middle. That's the self-locking mechanism. We got rid of it, which was pretty much the thing that was more complicated because it was, you know, it took too much time in terms of manufacturing. It was very expensive. It was not as efficient in terms of the submarine effect. So we got rid of 4, but we kept 5. Yes, sir. Okay, by crash testing, it's 750 newtons. 750 newtons, right? Applied normal to this face of the seat. Okay. Any other question? Yes, Professor? Mm-hmm. Okay, so pretty much at the beginning, what we were doing is that we kind of took our ideas to our client, and the first thing that was like the first filter, right? If they said yes, then we go on to testing or doing a simulation, probably like a finite element analysis. If they said no, we just go back to redesign or create another thing. Yes, sir. Any other question? So I guess that would be it. Thank you very much.
Right, so thank you everyone for attending our first day of the CQ-AState, the second edition. All right, microphone. Thank you everyone for yet again attending the first day of our CQ-AState second edition. We saw some amazing projects today, and believe me, tomorrow we will have more. Remember, please, that we will also have the poster session on Friday, and most importantly, we will have the award ceremony. After the poster session, it should be at around 4 o'clock. Judges, please remember to send your, well, essentially your grades for the presentation, just so we can actually have a good winner for this. So thank you so much and have a great day.